Great. Hello, everyone. Today we have the pleasure to welcome in our SciCons meeting James L. Howison. He's professor in the Information School at the University of Texas at Austin, and is about to present the Softcite project and the recent advances in software mentioned discovery in research articles. So James will cover what are the last improvements on this project, the creation of the Softcite gold standard dataset, and the Softcite mentioned finding tools. Also, we will discuss recent advancements regarding the software integration and explore also how software identifiers and registries are covered in the role of the SBOM, the software bills of materials. So this is a concept you will also talk about it. So please, James, the floor is yours.
Cool, excellent. Well, thank you very much. Makes sense. And hello to those of you that I've met, and hello also to those that I haven't. I'm excited to see this group advancing things. I want to say something before I start. A lot of what I'm going to be talking about involves work by many other people. So I'm speaking on behalf of a group. So let's keep that in mind. I also want to say I feel like I can. Um, so I've had an administrative appointment at my department for like the last year, and it's been kind of crazy. And I've gotten a little bit behind on some of the advances that people in the soft side and the SoFair project have made. So forgive me if I don't get all of that exactly right, but I will provide some pointers and people who are actually, there are some people on this call who know stuff about what SoFair is up to as well, and can provide a bit more there. All right. As I understand it, Psycodes is really interested in scientific software and its sustainability and its identifiers, and that is a topic close to my heart and to my work. So exciting to meet you, Cole. So first, we should start and say I'm a social scientist. So I'm interested in how people work together, particularly when they're building software. So that software work, think of, I started out interested mostly around open source software and thinking about why people get involved, how they work together, and then how the things that they build are different for that reason. So I got involved in thinking about software and science, basically with Jim Herbsleb at Carnegie Mellon. We sat down and we said, well, what's close enough to open source software that some of the things will be similar and some will be different. Um, and from that, we went on to say, well, we did a bunch of interviews with people who were building software and science. And, they told us lots of interesting things, but they said something that will not be a surprise to anyone here, which is, we could work much more on this if we got more funding. And we could get more funding if the people that used our code actually cited us. And, people would say, oh, well, we'd ask, so what proportion of your users do you think are actually citing you? And people would laugh, kind of sort of uh, in a resigned way and say, maybe 10%. I don't know. Um, so that got us started on understanding, well, how can we identify scientific software? What's standing in the way, and what difference would it make? So we got started on this project called Scientific Software Network Map, and you can see a little figure I drew there in 2010, kind of talking about, well, if we had the papers and we knew what software those used, and we knew what software was used in the presentation, we'd know what the complements are, we'd know that software depends on other software. Uh, and in that one, which we went about this in what in retrospect wasn't a great approach, which was really focused on asking people who were running the code to install software that told us about the software that was running and its dependencies. So people would call this. They'd sort of look at us and say, "So you want me to install scientific spyware?" And we'd be like, "Yeah." So that was one effort to kind of look at the runtime of scientific software and ask what's happening. Um, and simultaneously, we were also then interested, as you can imagine, in software citation. So when software mentions occur in publications. So that led to an interaction with Jason Prim and Heather Pivovar of Impact Story, now OpenAlex, and a software platform called Depsy, which really attempted to do this, but just for a couple of software domains and a couple of software um, ecosystems. Um, then I started working with the people who were running the Wispy workshops, people like Dan Katz um, and Arfon, talking about transitive credit, really thinking about, okay, even if we could identify the software that was at the first level that's actually mentioned in papers, that wouldn't capture the information that people are really after because it wouldn't understand the dependencies of the software that are being used. And so people's contributions would be masked from the top. And so Dan wrote this up as, the idea of transitive credit, that if we could understand the citations that a paper is receiving and then understand the role of the software within that, and then we understood the dependencies, we could understand the contributions in a way that those data could be marshaled and made available for people to make their argument for impact. Um, so that's how we got involved in this. And I think let's keep that as a really top level goal here, which is, that argument for impact is where we're ultimately trying to get to here, right? The reason we're gathering this information, at least from my perspective, is largely so that people can show why their work matters. All right. So, what I did early on was work funded by the Sloan Foundation and working with 30 students here at the University of Texas was manual annotations on just about 5,000 PDFs. I always look at that 4,971 number and think, we should have done a few more just to hit 5K. Um, so these were biomedicine and economics articles stratified over time. They worked for about 18 months, managed by doctoral student Hannah Cahoons. She did a great job there. And we started out just highlighting things in the PDF file, right? And of course, we had a coding scheme, which we'll look at in a minute. And uh, we had to get through all the gnarly questions of is a database software? Is Google software? Is uh, the MySQL system underlying a specific database? Is that software? Is cloud-oriented stuff? Is that software? And then what elements, do we want here? We want to understand the version. We want to understand the name of the piece of software. We might want to understand the creator of the piece of software as well. So that original gold standard data set was released. And at that point, Jason Priam introduced me to Patrice Lopez and the Grobid community. And we started working on really building out a model. And obviously, that's an area of Patrice's expertise, and eventually Luca Foppiano becomes part of that effort. Um, and so the Softcite Annotations 2.0 was a revision of the gold standard dataset led by Patrice and his small team. It's the same set of PDFs. In that process, we also refined the annotation scheme and we added subtypes of software, so things like languages and platform. And we also added the used, created, and shared labels, which really drew on some ideas introduced by the SomiSci project as well. So we'll talk about that in a second. So that's annotations about whether a particular piece of software mentioned in a publication was used, created, or like shared as in announced by this particular publication. Um, so on top of that, recently the SoFair team in Europe has expanded this data set and has expanded it in a couple of interesting ways, and particularly making it much more multidisciplinary. So one of the things we were finding in the models was that they worked okay, they worked well actually, in biomedicine and in economics. And they adapted to other fields not too badly, but definitely with a decrease in recall and precision. And so one of the things that SoFair was doing was expanding the number of PDFs, uh, working with core, and increasing the disciplinary coverage. So this in the slides there, you can see a link to a recent paper from SoFair that goes into detail on their expansions. Um, and so SoFair was also working to improve the Softcite code and to run it over a larger data set, working with core. So let's keep going. There we are. So this will give you an idea of um, the annotation scheme. So this is the Softcite 2.0 scheme here. And as I say, there are some changes that so far have introduced which are important as well. So the annotation fields in the data sets as things like software, um, whether or not it mentions string refers to a specific piece of software, should be the name, uh, or it could be something unnamed like a script. The publisher or the creator of the piece of software, and then we can see examples like GraphPad or NIH. It could just be an individual author or a team. The version, if that version was included in the text of the mention, and the URL. Now, something I've never understood super well is that the URL mentioned in the text seems to be has actually been an area that we've had low recall and precision, which is quite funny because you would think URLs are relatively easy to tackle. So that's one of the areas that we'll be pushing on in future. The other thing that we annotated, and I don't think that we've really used that this much in the data, was the certainty of the original annotator, right? So this goes to the question of machine learning pipelines, where the model training essentially expects like 100% certainty in the gold standard data set. As Patrice said to me once, he's like, yes, James, that's the gold part of gold standard. So, but we actually have some data about whether the original annotators were certain or not. And I think there's some interesting machine learning questions about whether and how we can pass those through. Um, so to give some idea about Grobid, so Grobid's a system that converts PDF, academic PDFs to TEI XML and then annotates elements within that. So it's a set of cascading models, and interestingly enough, underlying it is an annotated set of academic PDFs, and it's not a very big data set. If I understand correctly, it's only about 200 or 300 academic PDFs, but that was enough to get something that works really, really well. It definitely includes identifying references, and Grobid is primarily written in Java, usually run by a Docker, and then addressed with a Python client. Um, so it has a set of modules. Grobit has a set of modules within it. So things like identifying quantities, superconductors. There's datastat, which identifies dataset mentions. And then there's Softcite, which works as a plugin to Grobit to identify software mentions. So this will give you a little idea about how the Grobit software mentions module works. You can see on the right, we kind of pull the full text in the PDF using PDF Alto and then Grobid to create a structured document, do the software mention recognition. Another layer does usage detection. So this is the used, shared, or created labels, which creates these software entity candidates. And then some very, difficult and important work begins of like doing entity disambiguation, which Patrice calls entity fishing, which also tries to find out whether the references that are nearby the mention should be attached to the mention, right? Whether they are like specific to the mention, and then produces entities which are disambiguated, sort of. I would say that disambiguation is one of the biggest challenges, in this space. So if people have input on that, love to hear it. I can tell you a little bit about what we're planning in the future. You can see here the sort of performance levels that we achieved in Softcite, and Sofair has advanced this in some ways. And so you can see that we're getting, around the 0.8 recall and precision number, or F-score here, except in the URLs, which are low. I've always found that annoying. And then you can also see the sort of performance level that the software is able to get. And so that shows throughput speeds. And the answer to that is fast, but not blindingly fast. And I think it's worth pointing out that setting up Java virtual machines in distributed computing is an area that people have given a lot of feedback on that maybe could do with some updates, but that's the way it works at the moment. Let's see. So my group has run this model over 2 large-scale data extractions, and Sofair is a third one, right? So the first one was Cord 19 articles, so that was only about 300,000 PDFs. And within that, we found 115, so just under half had at least one software mention, and we found over 600,000 software labels. The second one was released last year. You can see it at that link. There, it's on about 26 million open access articles, and Patrice and I ran this with resources from the Texas Advanced Computing Center and also the Indiana Supercomputing Center. But those articles end in about 2023. And in that process, there was an interesting challenge, which was that the way Softcite works at the moment is it spits out individual JSON files. We had about 60 million of those. I don't know if any of you have ever worked with 60 million files, but you tend to run out of inodes. And that was a big challenge from me, for us. But a student, Daniel Beeson, helped figure that out, merged those 60 million JSON files to about 250, and then we're able to produce this data set as a Parquet files. The other thing in here is, if you've heard of the CZI software mentions data set, this was work that CZI did, so the Chan Zuckerberg Institute. And that was a different model, but also trained on the Softcite annotation. And it's remarkable because at the time, the Chan Zuckerberg Institute had access to proprietary literature as well as open access literature. And so they were able to produce software mention detections in the proprietary literature. So yeah, so that's a distinct data set, but also worthwhile. Beyond that, as I say, SOFARE has both improved Softcite and also worked with Core to produce a new data set of software mentions with a very similar schema. So this is this is what the data model for the extractions looks like, at least the way we published it in the extractions from 26 million articles. So at the top, we have a processed paper. You can imagine it has the DOI, author title, the date we processed it, and the source type, so PDF, TEI, XML, so on. So if the mentions were found, we have a software mention which has a raw name, the context, so the little chunk of text nearby, a version URL publisher, the Wikidata ID, if that was matched. That's part of the entity fishing. Then we have some subclasses. So implicit software is software without a name. So, we wrote a script to do X, Y, and Z. That would show up as implicit software, but the raw name is empty. A software environment is a type of software. So things like MATLAB, Bioconductor, R, or Python. And if we were able to detect it as a package, then we would have a component. So say Pandas should show up as a piece of software with the environment Python. What we don't do is go out and find, say, for example, the code meta files and figure things out from there. We're hoping others can pick up or we know others are doing that. But this is actually just looking in the text of the paper. So if this said the Python Pandas module, we would have Pandas as the component and Python as the environment. And of course, there's also some standalone software like Microsoft Excel that doesn't have components and environments. So Grobit, being very, very cool, also has if it's a PDF source, it has a PDF location box, and that's what enables the Softcite platform to draw the discovered mentions on top of the PDF. Sorry, I just saw Daniel's comment there about the URLs. Yeah, I reckon there's something going on in the pipeline. You're absolutely right, Daniel. Okay, so the last thing there is the purpose assessments. And these are another model, and this is the used, shared, and created, right? So there are 6 of these per article because there is a mention level assessment, and then there's a document for each of those: used, shared, created. And then there's a document level assessment. So this mention, so let's say Microsoft Excel is mentioned 3 times, you'd have 3 mention level assessments, so the nearby context. And then considering those three, what do we think the relationship between this paper and this mention are? So that's why there's 6 of those purpose assessments. Okay, so what does what do the results look like in our assessments we have here? This is comparison of reference manager mentions. So this is dear to my heart because I worked with BibTeX back in the day. And this was from a 1% random subset. So when we published the data set, we made a 1% random subset, 5%, and then the full. So, think this vertical axis should be 100 times higher. Um, so I think this one's kind of fun. You can see EndNote gets a significant amount of usage and mentions growing over time. BibTeX sort of got some uptake and then not so much. Mendeley and Zotero, plenty of uptake later in the sorry, not BibTeX is mentioned there. So BibDesk was what I worked on. And the mentions on that were like so low that you can't even see them. So but Zotero was there, and of course that was funded by the Sloan Foundation. So when I created these slides, I wanted to highlight that. All right. Cool. So, what does this actually look like on the platform? Well, it loads up an image of the PDF and then identifies things. So Clustal W there or ITASR, and then you can see the data that's produced on the right. So this is saying we think this software is used with 100% certainty. Always love to see 100%. Document level also used. And there's a reference, that Zhang reference there is identified as being very relevant to this piece of software, the ITASR. So that's what it looks like if you download and run the Docker image. That's what you'll find. And as I said, Luca has just updated the Softcite system to take into account the SOFARE improvements. And so those are available on the website as well. So I'm going to pause here for a second for questions there. And as I say, I know there are people who know the SOFARE work with a little more detail than I do. We could stop talk about that for a second. You can ask some more questions about the model. And then I'm going to go forward and talk a little bit about SBOMs and probably finally end with what we're hoping to be doing with OpenAlex in the next year. So I'll just pause for a second for questions.
I just have one quick one, James. Thank you.
Yeah.
So this has been really fascinating. Has there been some like a crosswalk made from the annotations, the schema that's used for these annotations and say code meta?
So there was a little bit of work towards that at a workshop that CZI organized like about a year ago. I think I do think it's worth doing, right? I think that so basically we started with the coding schemes, but I don't think that we ever like finished that work or published it. Yeah.
Cool. That's a low-hanging fruit. Maybe we can take on here.
Yeah, I mean, I think it'd be worthwhile, right? I mean, some of the things that we're identifying are kind of code meta fields, or should be. Um, I think we'll have one of the problems where with Moran, go ahead.
Thanks, James. That was fascinating. I wanted to jump in on the code meta mapping. So we
Yeah.
wanted to do it, but it's really hard because it's not the same object. It's about the relationship between articles and software. And while code meta is actually describing the software itself. So when we did it with Software Heritage using Quar Notify, we actually don't use code meta in that regard. So the crosswalk between two code meta was very difficult. But maybe it's something to explore more with the more brainstorming on how actually can we describe the relationship is possible to describe in code meta with the reference publication, but it's only for the one where the software is created and not when the software is used or referenced. So there's some difficulties there. Yeah, go ahead.
Daniel.
Yeah, I think that one also was a topic in the CCI workshop. I think it was more than a year ago. I think it was 2 years ago already.
I told you, there's like a missing year of me being like associate dean. I can't remember anything.
Yeah, so one of the subgroups that participated in doing something a little kind of related, which is from the paper, trying to see if there was a bidirectional link between the paper and the repo, and the repo and the paper. And then in the end, a paper in MSR, in the mining software registries, mining software repositories conference, where we put the results, and you see when this link happens, actually you can trust that that is the actual citation. So if you find something about that URL in the paper that you extract something from, then it could be pushed into the code meta of that paper, right? So
Yeah.
for that particular thing, it's a potential enrichment effort. For the others, yes, it's true that maybe you don't know that what it's being cited. So you could find a lot of metadata, but you don't know very well where to push
Yeah.
it, right?
I mean, it's interesting, Daniel, that you mentioned the repos, right? So this is something that came up at the workshop that our fund organized from Schmidt Sciences last year as well, right? So with input from other people, I think that I think that the context that's available for the mention in the paper and the context of the software in the repo combined with LLM techniques creates really makes disambiguation much more possible. So that's a set of
Yeah.
techniques that we're hoping to pursue in the next year with funding from Schmidt, and working with OpenAlex. So yeah, if you've got more on that, please do send it my way. And Daniel, I remember that project happening on the other side of the room, and I'm really glad to see that it ended up as a paper. In fact, the project I spent time on that workshop, on the software dependency paper, we actually tried to map out and identify the Nebraska packages, right? So packages that were crucial but maybe under-referenced. We we put that on archive, so I put that there, but we're finally really trying to get it published at PLOS, and I finally put in like third round revisions that were essentially, I don't know, there's nothing more we can do, accept it or don't. So hopefully that paper comes out soon. Makes sense.
Yeah, my turn to say as well, thank you for the great presentation. I really enjoyed it. I don't know if it's so much a question or comments on the importance of this presentation, because I'm very concerned with the topic of software disambiguation. I don't know if Anna is in the room, but with Anna Kelbert we got so I'm working at the BMAT Open and SUMAT, and we collect mathematics software entities from mathematical research papers, and we process with a kind of SQL request to check in the metadata what kind of software mentioned and what kind of what are the potential cited software, but we don't exactly check every of them. So we have a rough idea. We have a count of mentioned or mentioned or software string we find, but not everything is definitely checked by hand. And so it's really the topic of software disambiguation is big because we don't finally know, we're not completely sure what the real impact of the software that are indexed in Azumat. And we got the same I got the discussion with and I had this discussion with Anna Kelbert that is more on the topic of astrophysics, and astrophysics has the same problem, because I think there are many software that all have the same name. And
Yeah, they're all called star.
yeah, really. And so that's it's not so much a question from my own, but yes, because it's a topic itself, the topic of URL.
Yeah.
I mean, how we can disambiguate them, that's really complicated, especially when we just have a mention and we don't have the URI going with it in a paper. That can be really, really tough. That is, yeah. But just a word on this, yeah, for me.
Thank you, Maxence. Yeah, we should talk more on that. Alex, and then I think maybe Anna.
So yep, thank you for the presentation. It's very interesting, and I guess it gets more interesting as well as we go. So I have a question about if you looked into any preprints, because you mentioned articles, but did you have any from the datasets preprints? Because well, in some fields, you basically sometimes you only see the preprint, you never see the published version, or maybe the preprint has more mentions than what makes it to the published version. So I don't know if you.
That would be kind of fascinating, actually, and that's something I want to talk about in a few minutes. Is like, what are the impacts during the publishing process on what gets mentioned, and how should we deal with that? But in terms of the extractions that we've done, and actually maybe Moran knows a little bit more about the SOFAIR recent extractions, we include as many preprints as we could, right? So we're working with really just DOIs, and then the preprints have DOIs, and so they're very much part of it. But no one, I think, certainly haven't seen, has looked at kind of series of preprints and then a published article to see if the mentions change. I think that's an interesting idea.
From experience, we've seen that's kind of like my personal anecdote, that we see that in the preprint maybe you have a very strong reference to the software, like with a URL or even a DOI, and then like for typesetting, the whole.
Yeah, I mean, if you can find a
process.
data set of preprints that then lead to publications, so linked pairs of preprints and publications, then I think it'd be really worthwhile to run these models over that and report back.
Yeah. I assume from a bioarchive probably, or a medRxiv, because they have also the sort of like the timeline of a preprint and
okay, right, yeah,
versions.
cool.
So maybe
No, it sounds great.
Interesting.
It would be also interesting to see from in this sense, from an editor to another, from a publisher to another, if there is a style of accepting and publishing the software. If some are more careful than others, but it can be a bit politically sensitive. So
yeah,
but I would not be surprised to see interesting
things. Anna, did you want to talk about the SciX?
Yeah, I'd love to briefly tell you what we are doing.
Yeah,
so yeah, we're really interested in annotating software, because that's we're tackling that at SciX right now. So we're in the business of tracking mentions and generally tracking impact of both publications and software and datasets. So 3 of them, all of them, and other records as well. So we're including like proposals. But speaking of software specifically, so we're tracking impact through citations. We've been doing that for years. So if software is formally cited, we are tracking that. So we're indexing software records, and we are indexing anything that gets formally cited. So then we have preprints as well as applications, and we link them together. We have reference citation linkages for those. But if it's not formally cited, we also have this new relationship that we call mention. So it's one way it's mention credit. If it's software record, it gets credited, and if it's paper, it mentions. And we have that relationship for anything where we find a mention inside a preprint or a paper. And we do that for not just for software, we do it for other things as well, data sets and proposals, like I mentioned, like I said. But long term, we hope to do that with instrumentation, all kinds of stuff. But so software specifically, right now it's kind of limited to what we expose in the system, because we've only been able to unambiguously do this for DOIs, and only those DOIs. Yeah. So right now,
yeah. I have a question, which is, has anyone actually used any of the Softcite extractions, or were you running Softcite mention extractor directly?
Yeah. So we are training a model. So we're doing something related to it. So we're doing manual annotations that are much more detailed right now. So we include software, software version, publisher, that kind of stuff. But we also include data sets, instrumentation, events, like geophysical events, like an earthquake, or a magnetic storm, and obviously citations, institution, a bunch of others. So we're doing manual annotations for those, and the goal is that we're going to pre-annotate with. Actually, we're going to use your Softcite database, and we're going to use your pre-trained model and pre-annotate and compare,
Mm.
do a comparison analysis, and see what needs to be manually annotated on top of that, and then the hope is to retrain so that we can
Love it.
so
Yeah.
we can use it that way.
Fantastic. All right. Maxence, I want to chat about S-bombs a little bit. I'm mindful of time here, so
Yeah, thank you.
should we
Yeah,
do
sure.
that?
No worries. No worries.
Cool.
No worries.
All right. So some other work that I've been doing with Karthik Ram, who I'm sure some of you know, was really making an argument for the idea of an S-bomb as something that should accompany publications. So the high level argument here is here. I'm just sorry, I've got a few things up on the screen. I can't see my own thing. Okay. So if we think about four approaches to connecting papers and software, okay, one of them is advocacy around citing all software. Okay, so I think of the work that Ressa has been doing. I think of the work that the Force 11 working group on software citation did. And I think this is really important, right? And it essentially says, hey, you should cite the software that you use, and you should use this way of doing it. And this is important, and it has some limitations and it has some advantages, right? So the advantages are that direct citations are familiar to researchers. They're easiest to pick up in bibliometric systems. They require a formal citation object, so that obviates some of the finding strings business. But of course, it requires a great deal of change in practice, right? And so there are many proposals like this in the world that say, look, if everybody just did a small thing differently, everything would be better. Or as a friend of mine said, we wouldn't call it data mining if they didn't bury it. Could we just ask them to stop burying it? But there's another problem with the idea of citing all software formally, which really speaks to this idea of the preprint to the article, which is that the citation list is actually a very contested place, right? It's contested by authors, it's contested by editors, and Karthik and I did some interviews, and somebody said, "Yeah, we start out, we cite everything." And I look at it, and the biologists cite every piece of biology back to 1923. And by the time we do that, we've got 3 pages of citations or 6 pages of citations, and we're never going to get what we want into the reference list. So I think this is actually really meaningful, right? Like it's almost like if we tried to get every piece of software mentioned, or even more intensely, all of the dependencies of all of that software into the formal reference list, we would be blowing up the reference list to such an extent that it would actually lose its value, right? So we'd actually lose the signal and the importance. So in my mind, the reference list is the location for things that are pretty special. Right? And they're special for some reason, like they are the authors are writing to their particular community of practice in research. And they're mentioning these packages not for perfunctory reasons or reproducibility reasons, but for something linked to the scientific article. And that's actually a special process, and we should acknowledge that when we make these arguments about citing all software. So the second approach is extracting full text mentions. As you know, I care about this, but it is also very difficult. It's computationally expensive. And I can't tell you how many times in the last couple of years, and I'm sure this has happened to many of you as well, people are like, hey, LLMs can do this now. And I'm like, cool, yeah, you give me the budget for 60 million PDFs on Claude, and we can talk. But these insights are limited to tools deemed worthy of a mention. And of course, we don't have standardized practices of mentions, and so that makes it difficult. There is the advantage that that can be done without any change to current citation or publishing practices. So the third argument is that we should just publish all code by open science, right? So this is the idea that really the problem here is that the publication model is broken, and we shouldn't publish anything. We shouldn't acknowledge any publications that don't have all of their scripts. And once we've got those scripts, we can find all the dependencies really easy. Of course, this is a challenge for two reasons, which is open science is not yet a universal practice. It may never be one. Not all are incentivized to undertake this additional work, despite government efforts in these areas, and of course, a lot of efforts from scientists and the open access movement. And of course, there's always going to be proprietary tools that are not releasable. So that's a challenge there. The advantages, of course, is it gives the full code base. So you can do end user analysis code, you can find all the dependencies. There's a really happy time here for people who want to dive into the code side of things. All right, so the fourth one is the idea of a software bill of materials. So the SBOM, as it's called, is something created by a presidential order in the US. So Biden made an order that said that everyone who sells software to the federal government needs to provide an SBOM. And that SBOM is not a specified format, although formats have emerged. And that is basically a security effort that says, look, we're buying a bunch of things that are packaged up by software builders, and they've got dependencies in them, and we don't even know what we need to monitor for security purposes. So the whole SBOM thing is really coming from the open source supply chain security considerations, but it has created a way of listing citations. So it looks like Moran has posted something about SWIDs and SBOMs. So I love that because that's the connection we're trying to make here, right? So one of the things that SBOMs have required, just like software mentions and citations, is the idea of an identifier, and that has really been driven by package URL and then a VERS standard. So those standards have emerged. So one of the things I just wanted to so the idea here is that rather than trying to jam things into the software, into the reference list, we should be publishing SBOMs in one of the machine readable formats along with publications. And the software mining efforts should actually be producing SBOMs associated with a DOI. So really we have the SBOM can become a useful software metadata format. And I felt that this community was a really good one to talk about that. So let's do it. Tell me more.
Thank you, James. Thank you. Very interesting. Really liked it. I'm not sure. I mean, it's very conceptual to me. I'm not sure I'm getting every two cases of the SBOM. Would you say that I don't know? Would you say like it's like okay, it's a bit a gross idea, but I would be like citing a big table with every dependencies of the software, and so I mean something like that. I try to.
So yeah, so an SBOM is a machine readable listing of the top level packages, and then it can be expanded out to the full dependency structures as needed. So there's a bunch of tooling that both the open source and proprietary systems have made to take that initial list and turn it into the dependencies as well. Daniel, sounds like you've got some experience here.
So it reminded me a discussion that we had in Code Meta, and I think there is an open issue because someone brought in some SBOM specifications and started mapping them into Code Meta. And well, there is an open discussion, and I think that we even have one of the mappings from the SPDX SBOM. And we have to update it though, because it's an older version of Code Meta, but we are already going into that direction a little bit. So well, we are just talking about the mapping, of course, the crosswalk, which is what we focus a little bit more in Code Meta. But most of the properties that would be required to support an SBOM are in Code Meta, well, in Code Meta in schema.org itself, I think, because they have things like the running platform, the requirements, and the dependencies. So it should be possible to do. That's why we have the mapping so far. But usually this is a very political thing, no? Where different organizations want to fight for their own standards. And so far, I think what we have done is just stick to the crosswalk and how to translate one to the other.
Right. And I think that makes a ton of sense. When we talk about like software identifiers, for example, and I know other people are more experienced than I about this, I think we would be best served by looking to the SBOM world and the way it's done identifiers so that we can benefit from all of the tooling that's involved there. So when we look at like package URL as a ECMA standard, it's pretty basic stuff, but it does then allow us to connect with all of the other tooling. So I just wanted to share that. So CodeMeta's been doing some mapping. Do other people have thoughts on the package URL as an identifier scheme and how that can be adapted to scientific software at all?
Not on my own. I don't know. Yes, Mohan, please. I would
Yeah,
love to answer.
thanks, Maxence. Thanks, James, for bringing bombs here. Actually, it's very interesting to have this conversation, even though I wrote in the chat and I really think that SPOM is an overkill for research software. And there's a lot of difficulty with the current mechanisms to identify within the research landscape, because what we want from research software to be part of the research graph, so having a DOI, but then software is a kind of a living object with different levels of granularity, and the package URL is another level of granularity, which is not the highest level as in a project metadata record, and not a specific kind of a zip file or a file in a folder. So it's a very complex discussion, and SBOMs require some technical understanding. They are really used in software supply chains. I put the link here to show how one of our ambassadors is working on SBOM, but he works in industry. It's not academia. So I don't know how it kind of matches the use cases that we need for credit, for and other use cases, academic use cases.
Do you think that the idea of including a big table along with the publication, right? Which is what an SBOM would be, but just in a particular format. Do you think that has any chance/currency rather than trying to change citation practices to accompany papers?
I think that every time we ask something more from researchers, we lose them. So we need to find how we give services that help them do the research without doing the kind of administrative creation around it. So when there are automated tools to do it, and for CodeMeta, Daniel's team has worked a lot to do this kind of automatic tooling to get the metadata from the code. That's useful. But when you ask from researchers, another addition to
So Daniel, tell us about the automated tooling there, because I'd love to be updated on that. Because I agree. I mean, the incentive issues are fundamental, right? I mean, I was trying to upload to Figshare and I couldn't do it because it's like, give me some keywords. And I'm like, I'm just annoyed by this. Here's some crap.
Just first to respond to Morana on this question, that on the one hand, it is true that if we demand too much from researchers, they are going to complain. But on the other, in my experience, researchers always complain. And if there is a strong motivation, they will end up doing whatever is needed. Recently, for example, I've been running in several conferences, the ACM artifact available batch. And well, I can tell you that 80% of the people who applied got the badge, which required just doing a release of their code. And many had not heard how to do a release of their code and create a DOI identifier for their software, and everyone managed to do it without major complaints, right? Of course, some people complain, but you always get that. So if you have tools to support the creation of SBOMs or any other format, I think the way to sell this to researchers would be to get the actual added value, no? So is it reproducibility, which is probably could be citation/reproducibility, because if you have all the requirements that were used to actually build your code, then maybe this can be done implicit, like, well, out of your Docker container, you will get your SBOM automatically, and then everyone wins, right?
Right. And those tools exist to look at Docker containers and to produce an SBOM, right? I mean, that's the advantage that I see in terms of the automated tooling, is that, there are tools that exist that you point at any repo or any, in fact, Docker container and produce an SBOM like from that. That seems a pretty useful thing. And then if we can build that into the publishing cycle, but we can also go back in time, right? And we can say, look, this DOI, if you run Somisci on it, or you run Softcite on it, now we can produce an SBOM. And then we can publish that alongside the DOI. Now, it may be, as Moran said, that SBOM is the wrong level of abstraction. But I think that we need some work to kind of really look. There's this whole community out there. There's a whole set of tooling. Like, should we swim with them? Can we swim with them with just a little bit? Maybe the SBOM points to a code meta file, right? And so we enhance the SBOM. I think this is an area that could do with a lot of like really. Please write about it, investigate it, because I think it has potential.
And I put in the chat the link to the tool that Moran was referring to that my team worked on.
Nice.
Which is basically you give a GitHub or GitLab repo, and it will attempt to conflate all the metadata that it was able to find in the repository and the GitHub APIs and so on, and a little bit of the README into a code meta file.
So could we take the output of the software mentioned detectors, which will make a link from DOI to a word we think is software? Should a goal there to produce a DOI to code meta listing for each DOI?
So this accepts GitHub repositories, right? So if you take the URL associated with the mention, you could potentially generate the code meta file associated with that GitHub
Right. So
repository.
after you've mapped from the mentions to the repos, then you can generate a code meta file. So identifying the repos is crucial there. I mean, it's crucial for linking to any software heritage as well. Yeah.
Yeah. And I've noticed that because, I opened, I think, a few issues in code meta quite a bit ago, but sometimes, usually what happens is that a repository does not have a main reference implementation. It's that sometimes they have, I've seen papers up with 10 different repositories, right? Because in one, they have the evaluation of the paper. In another, they have one of the tools that they created. Another one, they have the dataset, because some people put datasets in GitHub too. And so on and so forth. So if you have a paper that, for example, implements a benchmark, I've seen up to many repositories being used in the paper. Sometimes the reference implementations is just a few of them. But I think someone was stating it in the chat that also the ability of citing, not only detecting the mention, but which mention or which mentions are the main software associated with the paper is quite valuable, especially for people looking for paper implementations. That's why, for example, paper with code was very famous, no? And at the moment I think in CodeMeta, we have a reference publication, but there is no way to state that, hey, I want to refer several things as the reference publication. You can refer multiple reference publications, but not a code deposit and a reference publication at the same time.
Yeah. All right. Yeah, I think we're hitting the hour here. So I appreciate all this input and encourage all of you to chat with me more. And I'm really excited with what this group is doing and to learn about each of these things. So thank you so much for the opportunity to spend some time with you all.
Thank you, James.
All right.
Thank you, James.
Thank you.